All right, let's start with Big Five, number one. We're going through all of these Big Five kinematic equations. There's a note here that says, though these equations only appear directly on 10.5% of the assessment, they can be indirectly linked to all of the problems related to acceleration and projectile motion. So most of the test is actually our Big Five kinematic equations. Remember, you will not get these on the test, so you have to memorize these formulas before coming in to take our test. So number 24, an object starting from rest. So if we know if something is starting from rest, our velocity initial is going to be 0, and that's meters per second. To accelerate to a final velocity of 3 meters per second. So our velocity final is going to be 3 meters per second, and this all happens in a time of 10 seconds. We're asked now to find the displacement of this object. So according to Big Five, number one, displacement is equal to 1/2 of our velocity initial plus our velocity final times our time. So delta S is going to be equal to 1/2 times 3 times 10. So our delta S is going to be equal to 1/2 times 30. Our delta S is going to be equal to 15. If we're talking about displacement, it's 15 meters. Number 25. While on a cycling trip this past weekend, Miss O'Connell accelerates rapidly as she went down a hill. At the top of the hill, her velocity was 3 meters per second. So her initial velocity at the top of the hill was 3 meters per second. And by the end of this hill, she's traveling at a rate of 8 meters per second. So her final velocity is going to be 8 meters per second. If this took her a time of 8 seconds, what was the length of the hill? So again, we're looking for displacement. So displacement is going to be equal to 1/2 of our initial velocity, which is 3, plus our final velocity, which is 8, times our time, which is 8 seconds.